All right, let's get started. 1.1 Chemistry and Measurement. So the first thing that we have to do is just kind of discuss what chemistry is. Formal definition is the study of matter and the changes it undergoes. So we're going to look at what matter is, what are the things that make up different types of matter, and then how can we alter those types of matter. I just put down a couple of different professions that rely heavily on chemistry or that are very chemistry related. An analytical chemist would be somebody that analyzes certain substances that are maybe made in the lab and need to be analyzed for purity or clarity or consistency. Biomolecular chemistry, biomolecular chemist is somebody that looks at biomolecules and sees how they interact and react with the body, so a lot with medical, a lot in the medical field. An environmental chemist is looking for ways to kind of clean up an oil spill, or to clean up, let's say if you've got a gas station that's been built and there's a leak in the gas tank that's underground, how do we clean that up? That's an environmental chemist. Industrial chemist, that's what I used to do. An industrial chemist will actually produce certain types of chemicals for a particular reason. I used to produce semi-metallic chemicals that would go inside of like iPads and computers. And then an organic chemist. Organic chemists deal a lot with polymers or plastics and how to make those particular items. So in chemistry, it is really important to understand how to measure. Just like baking, if you throw off the quantities in a baking procedure, you're not going to get a good apple pie. So you want to really understand how to measure, the tools you need to do it, and the units that are used to clarify and demonstrate the type of measurement that you're doing. In chemistry, we use a worldwide system of units called the SI units, or the metric system. And these are the 5 really big measurements and the base measurement unit for those particular systems. Okay, so we're not going to use the English system to measure in the lab. We will use it to do some converting, but we will not use inches or feet or pounds in the lab. Prefixes are always going to be used to show the magnitude of the measurement, so I'm just going to go through 3 of the more common ones. Kilo means 1,000. So for instance, there are 1,000 meters in 1 kilometer, so if you wanted to go a kilometer, you'd have to have 1,000 meter sticks laid end to end. Centi is 100th. So there are 100 centigrams in 1 gram, and if you want to understand what is a gram, it's about a paperclip. So if you think about a medium-sized paperclip, that's about a gram. So you'd have 100 centigrams in 1 gram. And milli means 1,000th. Okay, so there are 1,000 milliliters in 1 liter. And if you think about a liter, that's a liter bottle of water. I believe there's 355 milliliters in a can of soda, so it's a little bit less. One thing we're going to have to do is be able to convert from one unit of measurement to another unit of measurement. And we're going to use a process called unit analysis to do this. It's simply defined as converting one unit to another by canceling the particular units that we have. So I'm going to give a demonstration on how to do that. Let's say that I made a measurement and it came out to, let's say, 15.0 centimeters. And my book, or the question that I'm trying to work with, wants that final answer in meters. Now I know what a lot of you are going to be able to do. You'll look at this, you'll know that there's 100 centimeters in 1 meter. Since there's 2 zeros in 100, that means that you have to swoop the 0 here, or the decimal point here, to the left twice, and you probably would come up with the right answer, which would be 0.150 centimeters, and that is the right answer. However, I'm going to go through the painstaking process of unit analysis because it'll set us up for later on in the semester, and I will require that you do it this way. 15 centimeters. We're going to make that look like a fraction. And we're going to use a conversion unit to help cancel out that centimeter unit because we don't want centimeters. So just like in math class, if you've got something on the top of a fraction and that same thing on the bottom of another fraction, and those 2 fractions are being multiplied together, those units cancel out. The unit that we want from the problem is meters. And now I've got to ask myself something about this particular conversion unit. Do I want to say how many meters are in a centimeter? Probably not. I probably want to say how many centimeters are in a meter. And there's 100. So now I can get out my calculator or do this in my head, and I should come up with 0.150 meters after all is said and done. That's the unit analysis method. Okay? So when we're working on that in class, I'm going to require that you show your work because, like I said, it is going to build to something later on in the semester. In chemistry, oftentimes we're working with huge numbers, like for instance the number of atoms in a handful of sand. That's an enormous number. And we're also working with really small numbers, so like the mass of an electron, just incredibly tiny numbers. So instead of writing those really big or really small numbers, like for instance, if you had 18 milliliters of water, which isn't a lot, it's like a big test tube full of water, that equals about 6 times 10 to the 23rd molecules of water. So that is 6 with 23 zeros after it. You do not want to write that number, so that's why we use scientific notation, which I'm sure most of you are familiar with. Scientific notation consists of 2 parts. The first part is a number between 1 and 10. It doesn't have to be a whole number, it can be a decimal number. And then the second part is a power of 10 that we'll call x in my example here. Let me go back to the show. Call x in the example there. So those are the things that make up scientific notation. And let me just do a general conversion problem here real quick. If you've got, let's say, 2,700 grams, and I wanted to turn that into scientific notation, what I would do is find the decimal point in my original number, which is actually like right there after that last zero. It's just hiding. And then I'm going to take that decimal place and I'm going to swoop it so that it comes before the first non-zero number, which is this guy. And once it's there, I need to count my swoops. So that was 3 total swoops. 1, 2, 3 total swoops. That's going to give me my exponent. So now I'm going to write down the digits. Let's just go with 2.7, then times 10 to the third. Don't forget your unit. That's grams. So that's scientific notation. It's pretty simple. The difficult part with scientific notation is putting it into your calculator correctly, and we'll work with that in class. All right, that's 1.1.